Good morning, students. Students, if you remember, in our previous lecture, we discussed with you the gram atomic mass and the relative atomic mass. And what was the relative atomic mass? It was the mass of an atom of an element as compared to 1/12th mass of an atom of a carbon-12. And I told you that mass of one atom of an element was actually the average mass of all the isotopes available in the nature on the basis of their percentage abundance. Then I discussed the gram atomic mass. And I told you that the gram atomic mass is the amount of a substance. Gram atomic mass of any substance is the amount of a substance which contains same number of particles as were present in 12 gram of a carbon-12. And what was those number of particle code as? Those were called as a Avogadro's number. Am I clear? So in the previous lecture, we have discussed with you the relative atomic mass and gram atomic mass. I hope you must have understood this. We'll continue from where we left last time, and today we start our discussion with the discussion of relative molecular mass, and then after this we will discuss gram molecular mass and the Avogadro's number. Now relative molecular mass. Relative molecular mass. How do we account for the relative molecular mass? So relative molecular mass. Relative molecular mass. Relative molecular mass can be written in short as, it can be abbreviated as RMM. Relative molecular mass is the ratio of the mass of one molecule of substance compared with 1/12th mass of one atom of a carbon-12. So, relative molecular mass RMM, this will be equal to mass of one molecule of substance, mass of one molecule of substance as compared to 1/12th mass of one atom of a carbon-12, as compared to 1/12th mass of one atom of a carbon-12 here. So, relative molecular mass will be equal to mass of one molecule of a substance as compared to 1/12th mass of one atom of carbon-12. One atom of carbon-12. See very carefully, student. The comparison has been made with 1/12th mass of one atom of a carbon-12. But here the mass of molecule is compared. In the relative atomic mass, mass of atom was compared. In fact, the average mass of an atom of isotopes was compared. Here, the mass of one molecule of substance as compared to 1/12th mass of one atom of a carbon-12. Comparison is again done with 1/12th mass of one atom of a carbon-12, but in this case, it is a comparison of a mass of a molecule, not the mass of an atom. Secondly, molecules does not have their isotopes. So, in the relative atomic mass, average mass of the isotopes was considered. Here the average mass of molecule is not possible because the molecule does not have their isotope. So, we define relative molecular mass as a ratio of mass of one molecule of the substance as compared to 1/12th mass of one atom of a carbon-12. Am I clear? I hope you must be getting what I want to teach to you. Compare the mass of one molecule of substance as compared to 1/12th mass of one atom of a carbon-12. As for example, if I say mass of hydrogen, just see I am writing here as a molecule H2. Mass of hydrogen molecule is 2.016 AMU. It means one molecule of hydrogen is 2.016 times heavier as compared to 1/12th mass of one atom of a carbon-12. And 1/12th mass of one atom of carbon-12 was called as one atomic mass unit. If I want to convert this mass into gram, how will you convert atomic mass unit into gram? By multiplying with 1.66 into 10 raised to power minus 24. So, if the mass of one molecule is to be calculated in gram, this will be equal to 2.016 into 1.66 into 10 raised to power minus 24 gram. Am I clear? This is the mass of one molecule of a substance in gram. Or simply, how will I do? 6.02 into 10 raised to power 23 molecule of hydrogen have what mass? 2.016. Calculate the mass of one molecule of hydrogen. Now look at the point of a difference. If I say the mass of hydrogen molecule is, if I write down this way, mass of hydrogen molecule is 2.016 gram. There is a definite point of a difference between this mass in gram and this mass in gram. Any mass expressed in a gram is gram molecular mass if it is for the case of a molecule. So this I will say is a gram molecular mass of a substance. This was relative molecular mass of the substance. Why relative? In relation to? In relation to what? 1 by 12th mass of one atom of a carbon-12. When I say gram molecular mass of hydrogen is 2.016 gram, it is the mass of how many molecule of hydrogen? 6.02 into 10 raised to power 23. It was the mass of one molecule. Mass of one molecule expressed in gram is multiplied by 1.66 into 10 raised to power minus 24. But this mass over here, it is a mass of how many molecule? 6.02 into 10 raised to power 23 molecules of a substance. I think I shall be very, very clear. And whenever the mass of 6.02 into 10 raised to power 23 molecules are expressed in grams, it is called as a gram molecular mass. So how do I define the gram molecular mass? In a very, very layman's language, the mass of a molecule expressed in a gram is a gram molecular mass. Or the amount of a molecule which have a same number of atoms, same number of atoms as were molecules as were present in 6.0 as were present in 12 gram of a carbon-12, as were the number of atoms in a 12 gram of a carbon-12. So if I define the gram molecular mass of a 6.02 into 10 raised to power 23 molecule expressed in gram is gram molecular mass, or the molecular mass of a molecular mass expressed in a gram is called as a gram molecular mass. Am I getting clear, student? So if I write down the word gram molecular mass, gram molecular mass, gram molecular mass is written as G, M and M. This is gram molecular mass. Gram molecular mass will be mass of molecules expressed in grams, or mass of 6.02 into 10 raised to power 23 molecules. Expressed in gram is called as a gram molecular mass. So molecular mass is expressed in gram is a gram molecular mass. To be in a very simple language, molecular masses expressed in grams, molecular masses of how many molecules? 6.02 into 10 raised to power 23 molecules. Am I clear? Let me write in the mass of molecular mass of 6.02 into 10 raised to power 23 molecules expressed in grams is gram molecular mass. Is gram molecular mass. Am I clear, student? What is 6.02 into 10 raised to power 23 molecule? This is called as a Avogadro's number of molecule. Just look over here. If I write down H2SO4, it is sulfuric acid. If I write down, now I am recapitulating the atomic mass and the molecular mass. If I write down, the mass of H2SO4 is 98 AMU. It is the mass of how many molecule of sulfuric acid? 1. So it is the mass of 1 molecule of sulfuric acid. Am I clear? It is the molecular mass. If I write down H2SO4 mass and write it as 98 gram, it is the mass of how many molecules of sulfuric acid? 6.02 into 10 raised to power 23. So it will be a mass of 6.02 into 10 raised to power 23 molecules. If I want to express the mass of one molecule in gram, it will be 98 multiplied by 1.66 into 10 raised to power minus 24 gram. This is the mass of one molecule in gram. This is the mass of 6.02 into 10 raised to power 23 molecule in grams. Am I clear? This is the basic difference between the molecular mass and gram molecular mass, then the relative atomic mass and the gram atomic mass we have done earlier. Tell me, student, whether it is getting clear to you or not. 1 by 12 mass of one atom of a carbon 12 was called as the atomic mass unit. Suppose the question is, calculate the mass of 1.5 gram molecule of H2SO4. 1 gram molecule is a gram molecular mass. So how do I do? Gram molecular mass of H2SO4 will be equal to 98 gram. When I say gram molecular mass, I mean to say 1 gram molecule of sulfuric acid. These are one and the same thing, two different terms but one and the same thing. So 1 gram molecule of H2SO4 has what mass? 98 gram. 1.5 gram molecule of H2SO4 will have what mass? This will be equal to 1.5 into 98. And this will come out to be equal to 147 grams. This is how we have to do. Am I clear? So, by now in this chapter, what have we studied, student? We have done with you the brief classification, then measurement, significant figures, law of chemical combination, then relative atomic mass, relative molecular gram molecular atomic mass, relative molecular mass and the gram molecular mass. Now student, we will discuss what do I mean by Avogadro's law. Now the next is Avogadro's law. Avogadro's law. What is Avogadro's law, student? You have studied in the class 10th also. Under similar condition of temperature and pressure, equal volume of a gases contains equal number of molecules. So what does the law says? Under similar condition, under similar conditions of temperature and pressure, under similar conditions of temperature and pressure, under similar condition of temperature and pressure, equal volume of all gases contains equal number of molecules. Equal volume of all gases contains equal volume of all gases contains equal number of molecules, contains equal number of molecules, equal number of molecules. Am I clear? You have studied in the class 10th also. So if the volumes are same, the condition of temperature and pressure is not changed, then they will always contain the equal number of molecules. So under similar condition of temperature and pressure, equal volume of all gases, they always contain equal number of molecules. What do I mean by this? Suppose we have got the gas hydrogen and then we have got the gas nitrogen. Suppose we have 1 liter of hydrogen and 1 liter of nitrogen. In 1 liter of hydrogen, suppose in the question it is given, we have n molecules. So according to the Avogadro's law, if the volumes are same and the condition of temperature and pressure is not changed, then the number of molecules will also be same. So here what do we have? We will have n molecules. Is the law clear? Equal volume of all gases under same condition of temperature and pressure always and always contain equal number of molecules. Am I clear? Now, let me give you another question. Suppose we have a gas X and then we have a gas Y. Yes? We have a gas X and gas Y. If I say 100 cc of this gas X contains n molecules. My question is, if 100 cc of a gas X contain n molecules, how many molecules will be present in 25 cc of a gas Y? You may write it as a question. If 100 cc of a gas X contain n molecule, calculate the number of molecules in 25 cc of a gas Y. This is a question. So how will we solve this? By applying the Avogadro's law. What is that? We will make the volumes equal, and when the volume will become equal, the number of molecules will also be same. So how will I solve this? 100 cc of this gas contain how many molecule? N. 1 will contain how many molecule? N upon 100. Yes? If you take 25 cc by making the volume equal, so what it will be? 25 cc of this. It will contain how many molecule? N upon 100 into 25. We solve it up, it will come to be equal to n upon 4 molecules. So when the volumes are same, the number of molecules will also be same. Equal volume of all gases under same condition of temperature and pressure will always and always contain equal number of molecules. Am I clear? Yes. Now before I discuss the numerical part of this, let me explain to you the application of Avogadro's law. Application of Avogadro's law. Application of Avogadro's law. First is, it helps in stabilizing a relationship between vapor density and molecular mass. So it stabilizes the relationship between, between vapor density and molecular mass. Between vapor density and molecular mass. So it will stabilize the relationship between the vapor density and the molecular mass. How? You have done in the class 10th also. Vapor density is density of, vapor density will be equal to density of certain volume of a gas. Density of the certain volume of gas to the density of same volume of hydrogen, to the density of same volume of hydrogen, density of same volume of hydrogen at same temperature and pressure. This is the formula for vapor density. Density of same volume of hydrogen at same temperature and pressure. At same temperature and pressure. So what is vapor density? It's the ratio of density of a certain volume of gas to the density of same volume of hydrogen at the same temperature and pressure. Density of a certain volume of a gas is what? Density is mass per unit volume. So mass of a certain volume of a gas to the mass of same volume of hydrogen at same temperature and pressure. It is mass of certain molecules, certain volume of a gas mass of certain volume of gas to the mass of same volume of hydrogen at same temperature and pressure. Mass of same volume of hydrogen at same temperature and pressure. This will be the mass of same volume of hydrogen, same volume of hydrogen at same temperature and pressure. At same temperature and pressure. Am I clear? What is density? Mass per unit volume. So, mass of certain volume of a gas, and we have taken the mass of same volume of hydrogen at same temperature and pressure. If suppose we say in certain volume of a gas, am I clear? We have a mass, we have n number of molecules. So, we will write down mass of n molecule of a gas to the mass of n molecule of hydrogen at the same temperature and pressure. Am I clear? So, this can be written over here as mass of n molecules of gas. Since the volumes are same in this case, so we will apply Avogadro's law. Number of molecules will also be same. So, it will become mass of n molecule of hydrogen. This will be mass of n molecule of hydrogen. Of course, at the condition of same temperature and pressure. Am I clear? If instead of mass of n molecule, we take mass of one molecule of a gas. So, here we will also take mass of one molecule of a gas. Tell me whether I am getting it clear or not. So, this will be equal to mass of one molecule of a gas to the mass of one molecule of hydrogen gas. Mass of one molecule of hydrogen gas. Mass of one molecule of hydrogen gas is what? Approximately 2. And this will be molecular mass in gram, and this will become a molecular mass of a substance divided by 2. So, formula over here will be vapor density will be equal to molecular mass, mass of one molecule of hydrogen, 1 gram molecule of hydrogen in fact. This will be mass of 1 gram molecule of a gas to the mass of 1 gram molecule of hydrogen gas. Mass of, no doubt or no confusion, please do not write the mass of 1 molecule of a gas in atomic mass unit. The right term I am using is mass of 1 gram molecule of a gas, and that is a mass of 6.02 into 10 raised to 23 molecule. That is only when I can write down the mass as 2 gram. That is only when I can write down the mass as the molecular mass in gram. Fine. So, this one must not be confused, either it is in atomic mass unit or in gram. Gram molecular mass and a gram molecule of a substance means one and the same thing. So, this will be equal to 2. So, what will be the formula? Vapor density will be equal to molecular mass divided by 2, or molecular mass of the substance will be equal to 2 into vapor density. How have I established this relationship? By this. And here what have I used? Avogadro's law. When the volumes are same, the number of molecules will also be same. So, one of the major applications of the Avogadro's law is it helps in stabilizing a relationship between the molecular mass and the vapor density. Now, student, in the class 10th, you have studied that 1 gram mole of a gas occupies the volume equal to 22.4 liter. Yes or not? And how do you know this? That 1 gram mole of a gas occupies the volume equal to 22.4 liter. It is also established by the use of a law, and that law is Avogadro's law. So, second is it helps in calculating the gram molecular volume of the gas. Second application B, it helps in calculating or in determining gram molecular volume. Gram molecular volume. Which can also be called as a molar volume. And molar volume of a gas at standard temperature pressure is 22.4 liter. We very well know the relationship is 1 gram mole of a gas occupies volume is equal to 22.4 liter at standard temperature and pressure. Am I clear? So 1 gram mole of a gas occupies volume equal to 22.4 liter at STP. Students, way back, many years back, in IIT the question was asked that show that 1 gram mole of a gas occupies the volume equal to 22.4 liter. I can show it. Density of hydrogen. This is given in the question. This is 0.00009 gram per ml. This is a standard experimentation value, you know. So how will I go? 0.00009 gram of hydrogen has what volume? 1 ml. If you take 1 gram as a mass, it will be 1 upon 0.00009. Am I clear? And if the mass of hydrogen is taken as 2.016, it will come out to be equal to 1 upon 0.00009 into 2.016. On solving it out, it comes to be equal to 22,400 ml, which will be equal to 22.4 liter. Is it clear? So there is nothing to cram. Everything is a proof in a chemistry. What is the volume occupied by the 1 mole of a substance? It will always be equal to 22.4 liter. How have I established this? I have tried to establish by using Avogadro's law, which says that the volumes are when are same, the number of molecules will also be same. And somewhere it also helps in establishing the relationship between the molar volume and a molecular mass and a vapor density. Molecular mass and the vapor density. Now, you must be thinking, sir, where is the application of the Avogadro's law over here? This will be the volume occupied by gram molecular mass of a gas. Gram molecular mass of a gas contain how many molecule? 6.02 into 10 raised to power 23 molecule. So, and 6.02 into 10 raised to power 23 molecule is equal to how many mole? 1 mole. So, 1 mole of a gas indirectly occupies what volume? 22.4 liter. Am I clear? You must be sure what we are discussing. I can also prove that 1 mole of a substance contains 6.02 into 10 raised to power 23 particles. But that, of course, maybe in the class 12th I may teach. Here, if this is known to you, you have a sufficient knowledge as far as the class 11th is concerned. Is it clear? So, what have we discussed today, student? Relative molecular mass, the gram molecular mass, then the Avogadro's number, and the application of the Avogadro's number. Only 2 major applications I have done, although there can be many. It helps in stabilizing the molecular formula, it helps in determining the atomicity of a gas, but that is a theoretical value we have done in the class. Previous classes also no discussions over here, as has been done with you in the previous class. So I think these 2 applications must be very clear to you. Am I clear? Hopefully you must have been understanding the chemistry well. For any doubt, feel free to ask. Please make the notes. Solve the problems given in the book. It will help you a lot. We will meet again. With this words I am ending my lecture, and we will meet again in the next lecture, and in which I may discuss either some numerical problems or I may go for the mole concept, and then together we may discuss the numerical problems. So we will meet again in the next lecture. Till then, thank you.